while ago I got this kit, a CamJam Edu kit for the Raspberry Pi, which enables you to add sensors to the Raspberry Pi and do experiments and projects with it. It's a really, really good kit. It includes this temperature sensor, which is amazingly waterproof, and you attach it to your Raspberry Pi and you can take temperature readings. I made an alarm out of it, so I put it in my hot drink so it would make an audible alarm when my coffee was getting cold to remind me to drink it. It's called a DS18B20 temperature sensor, and it uses a kind of serial one-wire interface to give temperature readings, quite accurate temperature readings, to the Raspberry Pi. I've been really interested to know whether I could get one of these to work with a microbit, and I'd done some research on it and came to the conclusion that you could only program it using C, and it was probably beyond me, and I left it at that. But one of my colleagues found a MakeCode extension that makes this work, and I'll show you how to get it to work. So what we've got is we've got the temperature sensor. It is wired up, it's connected up to the microbit just using a breadboard, and you need one resistor. So I've got a simple 4.7 k ohm resistor and some crocodile clip leads, and I've got a MakeCode program flashed onto the microbit that just plots a bar graph of the temperature reading using this extension, this DS18B20 extension, which I'll show you how to add in a moment. Plots a bar graph up to 100. I don't reckon we'll be getting above 100 degrees, and then pauses for 2 seconds and then keeps going, which is fine. So what that means, if we actually run the program on the microbit, we'll see, hopefully, we'll see there, I've got a bar graph, and if I put my temperature sensor in my hot cup of coffee, we should see the temperature start to go up. There we go, it's climbing up, it's going up a bit more. Is it going to go up? There we go, it's rolling up like that. So there we go, so that sort of works. So I'll take it out. Oh, a bit hot, cool it down a little bit. What we can also do, if we are using the Chrome web browser, we can use a web USB functionality, which means we can actually take live data readings from the microbit and plot them and capture them on a computer. So what you do is you make sure you have paired your device. So click on pair device, find your microbit. You have to have up-to-date firmware on your microbit, but that's quite simple to update it if you need to. Click on connect, we'll pair it. Right, device is paired. Now if I download the code onto the microbit, the MakeCode program, we get a new option comes up here now. It says show console device, and our readings should appear on a bar chart, and you'll notice down the bottom here we've got numerical readings. You can actually save these and download them and export them as a CSV file and analyze them later in a spreadsheet. So if you look at the graph on the screen here, you can see the temperature's plummeting now. If I blow on it a bit more, it should be going down, down, down as it cools down a bit. If I put it back in my cup of coffee, we should see the temperature start to go back up again on the computer display. There we go, it's going up to 46, 50 degrees. It's getting higher and higher and higher. There we go, so we've captured that data. If I want to download it, I'll pause it, click on the download button. You can export the data, and it will export it as a CSV file, which you can open up in a spreadsheet program. So it's a great way of doing a bit of simple data logging. So we'll go back and look at the code here for the program. It's just sitting in a forever loop. It plots a bar graph of the temperature number scales it up to 100, but you can pick any number. You could pick a lower number if you wanted to get a bigger variation on the display of the bar graph, and just some sort of pause is good. You don't want it to take temperature readings too often. Let's have a look at how we made that work. So if you look on my blog post, I've got instructions for how you do this and how you wire it up. This is the wiring diagram. So there's a fritzing diagram here to show you how you wire up a temperature sensor. So all you need is a temperature sensor, a 4.7 k ohm resistor, and some wires or some crocodile clips, some way of connecting the 3 wires to the microbit. The ground wire just goes to ground. The yellow wire is the DQ wire, that's the data wire. It goes to pin 0 in this example. You could use another pin, but I've just happened to use pin 0. And the red wire is the power, so 3.3 volts needs to go in that. And we've got a resistor across there to limit the amount of current going through there. So how do you add the extension to MakeCode? The magic you need is this address here. So if I copy and paste, copy that there. If I go to MakeCode, and I'll go to extensions, and you want to add an extension, you just paste that URL into the box there and press enter, and the extension will appear. Okay, so it's not endorsed by Microsoft. It's a third-party extension. It's just warning you, and then the extension is there now, and it's ready to use. And that's how you get the DS18B20 blocks. There are only two of them: temperature number and temperature string. So they just provide the temperature readings as numbers and strings. I've used those in a couple of different example projects, which I'll show you. One will just show you the temperature when you press button A, just as an integer. It rounds the number up so you get a whole number. So it'll just say like 37, 38, 39 degrees as a whole number. Another project that I've got shows you slightly more accurate temperature readings. It's using the string block for that. And I'm using a substring of that just to basically truncate it to about 1 decimal place. It depends on the temperature reading, I think, but there we go. That's how it works. Show string, substring of pin 0, temperature string from 0 of length 4, and that will give you a temperature reading on the microbit when you press button A to 1 decimal place to give you a slightly more accurate temperature reading. If you have a use for that, let me know, or do anything with this. I could make another alarm to warn me when my coffee is going cold. It could also make the basis for a good weather station project, because this temperature sensor is an external temperature sensor, unlike the one on the microbit, which is built in to the board itself. It's built into the processor. This is an external temperature sensor, so you can put it outside. You can get more accurate ambient temperature readings using a temperature sensor like this than you probably could using the onboard microbit sensor.